Welcome to the Mind of STEM, where you get your daily dose of science, technology, engineering, and math. Now, last week, I did a video on the discipline of mechanical engineering. Now, this evening, I'm going to talk about the field of civil engineering. Now, by trade, I am a civil engineer. Now, civil engineering is one of the oldest branches of engineering outside of military engineering. Now, what is a civil engineer? And what does a civil engineer really do? Now, if you really want to get more into civil engineering, you can go into the information from ASCE, that's the Association or the American Society for Civil Engineers. That's an organization. Involves a lot of civil engineers. I'm a member of that myself, a student member. Now, what is civil engineering? Basically, civil engineering is an engineering discipline that deals with the construction and maintenance of physically and naturally built environments. Now, what does that include? Well, when you deal with civil engineering, a lot of the projects you are involved with are with public works, such as roads, bridges, canals, dams, airports, sewer systems, pipelines, structural components of buildings, and railways. Now, as with any branch of engineering or discipline of engineering, civil engineering is no different. It has its different sub-branches. And of course, again, as I mentioned before, civil engineering is the second oldest discipline after military engineering. Now, and it is defined to distinguish non-military engineering from military engineering. Now, why does that happen? Because civil engineering takes place in the public sector through municipal or from municipal through to natural governments or national governments. Again, the difference between military engineering and civil engineering, they do interact with government projects, but they're not military. Now, again, civil engineering takes place in the public sector from municipal through national governments, and in the private sector from individual homeowners through international companies. Now, you have your big companies like AECOM, PSI. Now, when it comes to civil engineering as a discipline, again, there are areas that you must have a lot of knowledge of. And with every other branch of civil engineering or engineering, because civil engineering is broken down, let me give you the subdivisions. Transportation. Now, transportation engineers, they deal with all of your traffic, trip distribution. They deal with your intersections, your pavement markings. They deal with your level of service. Your lightest level of service is LOS-A. Your heaviest level of service, that's what LOS stands for, level of service, is F. And when you have an F, you have a lot of congestion. They're the ones who try to figure out your traffic problems, your cycle length of your traffic signals. Then you deal with your geotechnical engineers. They're responsible for everything that is soil related. They are ones who design retaining walls to hold back your soil, because the pressure on a retaining wall is always triangular. And you need something to hold that soil back. We call it retaining wall. There are different types of retaining walls, like MSC, Mechanical Systems Engineering. Call it an MSC wall. A lot of your geotechnical type of stone like 57, 73. Your pavements. When we get more into structure, that's when your pavements come out, or transportation could use pavements as well. But you also have surveying. You need somebody to go out there and locate all your points. Surveyors do stakeouts for construction. They do estimations, some of them. Set grade stakes. You need to know what your cuts and fills are. So when it comes to some branches, civil engineering is involved in everything. Geography, geology, soils, hydrology, environment, mechanics of the fields. Now, again, when it comes to education, if you want to become a civil engineer, you must have a bachelor's degree from an ABET accredited institution. Now, bachelor's degrees take 4, some take 5 years. But you must have that as a requirement. And then once you get out of school, and I urge everybody, you graduate from any engineering program, take the fundamentals of engineering exam while it's still fresh. It's a very difficult exam, but that is your path to licensure. And as a civil engineer, you want to be licensed because you're working on a lot of infrastructure. Now, architects have to be licensed, landscape architects. Most fields that are involved with architecture, because a lot of your buildings, architects design your buildings. When it comes to civils, they do the structural components. But usually on the building, the architect is the lead. So the architect usually hires an engineering firm. And that engineering firm could supply the geotechnical work, could supply the surveying work, it could supply the structural work. But nevertheless, when you are working on infrastructure, you got to deal with the safety of people. So you have to be licensed. Again, when it comes to civil engineering, as I spoke before, there are a number of sub-disciplines within the broad field of civil engineering. Now, general civil engineers work closely with surveyors and specialized civil engineers to design grading, drainage, pavement, water supply, sewer service, dams, electric and communication supply. Now, general civil engineering is also referred to as site engineering, which is a branch of civil engineering that basically focuses on converting a tract of land from one usage to another. Now, site engineers spend time visiting project sites, meeting with stakeholders, and preparing construction plans. Civil engineers apply the principles of geotechnical structural engineering, environmental engineering, transportation engineering, and construction engineering to residential, commercial, industrial, and public works projects of all sizes and levels of construction. Now, of course, you have coastal engineering, and that's basically concerned with managing coastal areas. In some jurisdictions, the term sea defense and coastal protection mean defense against flooding and erosion, respectively. The term coastal defense is more than a traditional term, but coastal management has become more popular as the field has expanded to techniques that allow erosion to claim land. Again, one of my favorites, construction engineering. Now, construction engineering involves the planning and execution, transportation of materials, site development based on hydraulic, environmental, structural, and geotechnical engineering. Now, as construction firms tend to have higher business risk than any other types of civil engineering firms do, construction engineers often engage in more business-like transactions. For example, drafting and reviewing contracts, evaluating logistical operations, and monitoring prices of supplies. Then, if you live out in California, there is earthquake engineering, and that involves designing structures to withstand hazardous earthquake exposures. Now, earthquake engineering is a sub-discipline of structural engineering, which structural engineering is a subdiscipline of civil engineering. Now, the main objectives of earthquake engineering are to understand interaction of structures on shaky ground, foresee the consequences of possible earthquakes, and design, construct, and maintain structures to perform at earthquake and compliance with building codes. When you deal with any type of engineering, you have to understand building codes. Now you have environmental engineering. That's basically a contemporary term for sanitary engineering. Now, through sanitary engineering, traditionally had not included much of the hazardous waste management and environmental remediation work covered by environmental engineering. Now, public health engineering and environmental health engineering are other terms that are used, because environmental engineering deals with treatment of biological, chemical, or thermal waste, purification of water, air, and remediation of contaminated sites after waste disposal or accidental contamination. Now, amongst the topics that are covered by environmental engineering are pollutant transport, water purification, wastewater treatment, air pollution, solid waste treatment, and hazardous waste management. Because environmental engineers administer pollution reduction, green engineering, and industrial ecology. Because environmental engineers also compile information on environmental consequences of proposed actions. Then, of course, there's geotechnical engineering. And you can say geology is all part of it too, because basically geotechnical engineers study rock and soil supporting civil engineering systems. Now, they have to have a lot of knowledge of soil science, material science, mechanics, and hydraulics. And that's basically needed because you have to apply to safety and economically designed foundations, retaining walls, and other structures. Now, environmental effects, when it comes to geotechnical engineering, they're used to protect groundwater and safely maintain landfills that have spawned a new area of research. Now, that's called geo-environmental engineering. Now, identification of soil, or not soil, but soil properties, basically presents challenges to geotechnical engineers. Boundary conditions are often well defined in other branches of civil engineering, but unlike steel or concrete, the material properties and behavior of soil are difficult to predict due to its variability and limitation on investigation. So furthermore, soil exhibits nonlinear, or we say stress-dependent strength, stiffness, and volume change associated with shear stress. So got to study soil mechanics. Then there's material science and engineering. There's structural engineering. It's basically concerned with structural design and structural analysis of buildings, towers, flyovers. When it comes to overpasses, tunnels, offshore structures like oil and gas fields in the sea. Then you have surveying. That's the process by which a surveyor measures certain dimensions that occur on and near the surface of the earth. Then there's land surveying, transportation engineering, municipal or urban engineering, civil engineering systems. Now, civil engineering systems, we used to call that urban engineering. That deals with more your project life cycle from conception through planning, designing, operation, decommissioning, and you have water resources engineering. But overall, civil engineering is a good field. It's always going to be stable. There are lots of areas you could go, but in college you take a general civil engineering type of program. You get your master's in any specialization, but you have to get your license. Once you get your license, you can sign plans and you can open up your own civil engineering firm. Now, just wanted to give you an overview in this video, and I thank you for taking time to listen to the topic of civil engineering right here on the Mind of STEM, where I'm giving you a daily dose of science, technology, engineering, and math. If you like what I just presented, please comment, share, and subscribe. Now, this channel is for learning only, but I will post this video on my Facebook and Twitter pages. Till next time, that concludes this video. Remember, knowledge is power. Keep learning. I just want to say a pleasant good night. Once again, my name is Leon Jones, and always keep your mind and options open.